Hi, and welcome to another little session for us. And today I want to look at how we can use what's given to us to help us understand what's involved in a chemical. All right, so we're going to look at a lesson today on writing chemical formula and understanding what they mean. Now, chemical formula, they're like shorthand. And what they are simply things that allow us to see what goes on inside a chemical. All right, so when we're doing this stuff, we have to be really mindful of it, and it makes it so much easier for us to do. So here's an example of a chemical formula, and I'm going to use the pencil a little bit today as well. I'll use a different colour, nice bright red colour. Right, we can see with the formula we've got a capital H, a capital N and a number. Now this is quite common for formulas. And every time we see a new capital letter, like here, we see we've got a capital N, that's one letter, and a capital H. Now the N, this N stands for the chemical involved, and N stands for nitrogen. Whenever we see another capital letter, it tells us that there is another chemical involved. Now, by definition, a compound is a pure substance that has two or more elements bonded together. Right, now here's our next one. H stands for hydrogen. Now at the end I'm going to give you a little bit of a worksheet to do on this, which has got the periodic table, which gives you what the letters stand for. In other words, what N shows you means nitrogen, H means hydrogen, etc. And it shows other things as well. Now, while we're looking at that, let's look at this thing here. The 3 refers to what's in front of it. So in other words, there are 3 H's. So you might say, well, why isn't there a 1 written here for 1 nitrogen? Well, what scientists like to think, and what chemists in particular like to think, is the fact that because the symbol is written there, the N is written there, that means there is 1. If there were more than 1, we would show that in numbers. So here we can see, if we think about all the stuff we can see on this thing, we should be able to see that we've got 2 chemicals, nitrogen and hydrogen, forming a small little structure, and it has 1 nitrogen and 3 hydrogens. Right, so that was 1 N to 3 H. So it's a ratio, if you like, of the number of each of the elements. Now this follows all the way through. Oh, by the way, this is a chemical we have used a couple of times in the lab, and its name is ammonia. It's a common chemical, and in many ways I would expect you to know that. Alright, so let's keep moving on. So let's do the same thing with this one. Water has a formula, H2O. Everyone knows that. So let's have a look at what this means. Well, H stands for hydrogen. O stands for oxygen. That's atoms, not gas. We of course know that the air we breathe, the oxygen in it, is written as that, which means there's 2 oxygen atoms together. Right, just like the NH3. Right, so there were 3 H's, now we've got 2 O's. That's the oxygen gas, but this is slightly different. And so we could see here that we've got 2 H for every 1 O, or just O we could write it as. So 1 is confusing a little bit. So in other words, we've got 2 hydrogens for every oxygen. Exactly what we saw a minute ago. Now there is one more thing. We actually call water, we give it a special name. And it's a small group of elements that can act together as one. And they can exist, and they do exist in little groups. And this little group is called a molecule. Alright, so we're going to see all these little things. Most of the things we're looking at today are little molecules. Alright, let's move on. What other ones, common ones have we got? Well, next one is carbon, CO2. And for those who don't know, that is carbon dioxide, as it says there. Right, C stands for carbon, O still stands for oxygen, and we can see there is one C combined with 2 O's. Alright, so taking that one step further, we could see now there are 1 plus 2 or 3 atoms per that nice word I just mentioned, molecule. So this formula is actually showing us quite a lot. We sometimes don't appreciate how much it's showing us. Right, let's look at another one. This stuff we have used in class as well. It's that powder we've added to acid a couple of times, and its proper name is, we have 1, 2, 3, 4 capital letters this time, and we call it sodium bicarbonate. Right, so let's look at what this means. I'll go to my red again, so I've got a nice bit of colour there. Na is sodium. Basically because the N's were taken in the names. H is equal to hydrogen still. C is equal to carbon. And O is still oxygen. Right, now our ratios. We've got 1 Na to every 1 H to every 1 C to every 3 O's. Right, so everything we've been doing all the way through from simple, even though it gets more complex, we simply just follow the same rules. Oh, this looks terrible, doesn't it? This looks really, really complicated, but it's not if we follow the same rules. Now this stuff, by the way, it's a very, very complex formula, but really it's clay. All right, so let's start looking at the numbers of capital letters. So I've got 1, 2, 3, 4, 5. But hold on, O and O, same thing. Same thing, they're still those. So let's go down here, let's work it out. Al stands for aluminium. Si equals silicon. It's an element. O still stands for oxygen, and H still stands for hydrogen. So there are 4 elements involved, but let's look at the ratios. This gets tricky. Now the reason it gets tricky, we've seen before that when it's behind, those 2 apply to that thing. Those 2 apply to that thing. Those 5 apply to that thing. These 2, like math, they apply to everything. When you've got the bracket, they probably do everything in the bracket. So there's 4 O's and 4 H's. Now let's count them up. So I've got 2 ALs for every 2 SIs, for every 5 here, plus another 4 inside the bracket, 9 O's to every 4 H's. There's an awful lot of chemicals put together inside that clay, as you'd expect when we think about clay. Right, now here's the super challenge. This stuff here is stuff that a lot of people like to know about, but very few people like to handle. And it's called nitroglycerine. It's the stuff that goes boom. Mr. Nobel of the Nobel Prize made all of his money by converting this into a safer form, which we should call dynamite. All right, this thing here in green is how it's put together. This thing underneath is the ratios. So let's work out what's in it. So we can see from this bottom one that we've got 1, 2, 3, 4 capital letters. We've got C for carbon, H for hydrogen, N for nitrogen, and O for oxygen. And our ratios are 3 C's to 5 H's to 3 N's to 9 O's. And that's how we use our formulas to tell us what's going on. You can see there's an awful lot there. Now, in this case, because it's a bit bigger, sometimes we actually call it a formula. This we might call a formula unit. In other words, all the things that make up this compound. All the things that make up this compound. I'm getting very, very sloppy with my handwriting. So I'll try to fix that up. And this formula, a particular formula, contains 3 plus 5 is 8, plus 3 is 11, plus 9 is 20 atoms, or 20 bits of elements. And I think we can leave it there. There'll be some more about some basic chemistry because it's something we need you to be a little bit more knowledgeable about. Righto.